Whew. All right. Cutting our teeth here with doing some math, but now we're on to the algebra. Lots of letters, a lot of symbols, so you're going to be moving around. Some things we know, some things we don't know. Usually we solve for the thing we don't know, right? So when we start talking about algebra, and then we are going to end up talking about, in round 5, Pythagorean theorem, SOHCAHTOA, sine, cosine, tangent. Guys, this is really the bread and butter of the class. Unit conversions will be there, okay? But using algebra to solve, and there's gonna be times where we just have long expressions. I think I had a student that said, Dr. Ray, it's like we just wrote a sentence there. I know, guys, sometimes it gets a little long, but you're really gonna have to fortify your algebra, right? I don't know if that's the right word, but or fortify yourselves ready to battle with the algebra throughout the semester, right? We're going to be using it every day in class. Hopefully you use it when you're solving for homework and when you're solving problems, right? Because that's part of that critical thinking. Can you not think in specifics? Can you think in general terms? It's a very important skill to have. Okay. So given the equation, V2 equals V1 plus AT, right? That's a real equation you might see. Solve for A. All right, here we go. That would mean if we were going through this, it means V2 you know, V1 I know, T I know, and then it's not going to quite work, but I don't know what that A is right there. Okay, so that's what I'm trying to solve for. I'm trying to solve for that A, for example. How do I get A all by itself? I got to think about what are the operators happening around it, right? Here's a plus. There's an addition, right? So I want on this side with the A. So I need to get rid of that thing that's being added. How do I get rid of something that's added? You subtract it. So what do I need to subtract? I need to subtract V1, right? Minus V1. What you do to one side of the equation, you have to do to the other side of the equation. So what happens is when you do V1 minus V1, that equals 0, right? It doesn't necessarily cancel. It's just you're adding it to 0. It's no longer on the right-hand side, but now it's on the left-hand side. So I have V2 minus V1 is equal to A times T, plus 0 if you wanted to write that to be really explicit, but it's not there. All right, now I have acceleration times something. Acceleration times time, right? Times being the multiplying operation, and then we have time being the quantity that's being times by acceleration. How do you get rid of multiplication? You divide. So I need to divide this side by time. And notice if you divide t by t, you get 1. So it's not like it's canceling, it's just dividing to 1. You can say cancel if you want, but you're really dividing to 1. Do that to both sides. Now I just don't divide the V2 and I just don't divide the V1, right? I could do V2 divided by T minus V1 divided by T, but usually just take that whole numerator, everything that's up top, and divide it by T. So if you want to write this all nice and neat, acceleration is equal to V2 minus V1 divided by T. Acceleration is a velocity over a time. All right. Let's go on to number 2. Given the equation, xf is equal to x0 plus v0, right? So xf would be like a final position. x0 would be like an initial position. Plus v0, that's like an initial velocity, times t, which is time, plus 1/2 times acceleration times time squared. Okay, that's a mouthful, right? That's why we just write it out in equation form, guys. Once again, we're going to solve for the acceleration. Let's see, before I only had one thing that was added. Now I have 2 things that are being added. So what I have to do is I have to take both quantities, right? I have to take this x naught and subtract it on both sides. And then I would need to take the v naught times t, the whole quantity, and I would subtract that on both sides. Right, so I would do a minus v naught t, and those would add to 0 over here. And then I would have on this other side xf minus v naught t, but I also want to subtract that x naught. I'm going to do that at the same time here. I'm going to subtract x naught from both sides. So I'll go with A, I'll keep it with the orange, minus x naught here. So now on the right hand side, the x naught is gone, it's added to 0. The v naught t is gone, they've added to 0. And so I'm just left with, on the right hand side, 1/2 times acceleration times t squared. Okay. Now I'm still focused on the right hand side, that acceleration. Now I'm multiplying by two things. I'm multiplying by a 1/2, and I'm multiplying by a t squared. How do you get rid of these things? Well, I'll use an eraser here, and I'll rewrite this 1/2 as a t squared over 2. So then how do I get rid of that t squared and that 2? Well, t squared is being multiplied. So once again, I need to divide. So I'm going to multiply this as 1 over t squared, just the same number, right? So those t squareds will divide to 1, but I have to make sure I divide the other side by t squared as well. Now, a is not all by itself yet. I have to take that 1/2 and get rid of that 1/2, right? That's the same as dividing by 2. So to get rid of division, I have to multiply. So I have to multiply both sides by 2. So that 2 divided by 2 divides to 1. And then when I come over here, I have to multiply that whole numerator by 2, right? I just don't take that 2 times the final position. I don't take that 2 times the initial velocity times t. I don't take that 2 just times my initial position. It's the whole thing, right? So you just got to be careful with that quantity there. So if we are going to then rewrite this as one neat little package, a is equal to 2 times final position minus initial velocity times time minus initial velocity divided by time. So let's do a unit check on this, right? Let's do a unit check on this. This is going to be meters, right? Final minus meters per second times a second minus meters all over seconds. So these seconds right here, I have to order these, right? I have to start here in the parentheses. Seconds will go away, which means I'll have a meter minus a meter minus a meter. That's good. I can only subtract meters from meters. I can't subtract centimeters from meters. They're not the same units. I can't subtract oranges from apples because oranges are not apples, right? They're both fruits, sure. But you have to have the same units in order to make this now a single meter unit. And I end up with meters per, oops, what did I forget? I forgot that squared, didn't I? Golly, that's why you guys should need to do this, right? It's so helpful, right? The worst thing is when you just forget to bring along one of those squares, right? Meters per second squared, and that is the correct unit for acceleration. All right, number 3, there we see that little yield sign again, right? Which means y'all gonna work on this one. You have 2 equations, 2 unknowns, right? 2 equations, 2 unknowns. You want to solve x in terms of z. So we have x, y, and z in the first one, x, y, and z in the second one. And so what you want to do is you want to eliminate y. Eliminate y. So how do you do that? Well, you have in the second equation, y is equal to x and 3z. You're going to need to substitute that x plus 3z into the y of the top equation. All right, if that doesn't make sense, guys, we got some work to do in terms of the algebra, but for now, try to work through it. Take that equation, number 2, I'll write that right there. Take equation 2, bottom, right? Take that little x plus 3z, substitute it in for the y, solve for x. So you want to simplify to where all the x's are on one side, all the z's are on the other side. All right, everybody, good luck.